Hello students, welcome back to Organic Chemistry. In the last lecture, I have taught you what are functional groups and what are homologous series. Now it's time to learn the nomenclature of organic molecules. The organic molecules can be named by their common names, also known as trivial names, or by the IUPAC names. First, let's see what are common names. Common names are usually derived from the source what they are extracted. In olden days, when some organic molecules are extracted from a certain compound, right? So it usually depends on that molecule. For example, formica, right? It means the compound present in the ant sting, right? So it's nothing but the formic acid. Formic acid. And the acetic acid, the one which is present in the vinegar, right? So that is nothing but acetic acid. These are the common names. Now, what is IUPAC? IUPAC stands for International Union of Pure and Applied Chemistry. So this is a union which decides the rules to name the organic molecules so that there is a uniformity when we name the organic molecules. For example, formic acid is named as methanoic acid. That is the IUPAC name. Acetic acid is named as ethanoic acid. There may be some ambiguity when we use the common names or trivial names, but when we use the IUPAC names, we will always have only one nomenclature for the given molecule. From the exam point of view, it's better to know the common names as well as IUPAC names for the molecules. Let's start by naming the alkane molecules. Nomenclature of alkanes. Alkanes are the molecules with the general formula CnH2n plus 2. What does that mean? When n is equal to number of carbons, right? If n is 1, then the molecular formula is C1H. 2 plus 2 would be 4. That means CH4. Then what do you call this molecule? It's called as methane. The meth refers to the number of carbons. If there is one carbon, we call it as meth. And what is this ane? It is a suffix. Alkanes always have the suffix ane. If n is equal to 2, then the molecule would be C2H6. Since there are two carbons, the root word is eth and the suffix is ane, ethane. It's a ethane molecule. So how can you write a ethane molecule? You can write like this. This is condensed structure. If there are 3 carbons, then the hydrogens must be 8 because it's a homologous series. In the last video, I taught you what is a homologous series, the one which differ by a CH2 group, right? This is a higher homolog of C2H6. And what do you call it? Propane. For a propane, you can even write a bond line structure like this. The higher homolog of propane is butane. And since there are 4 carbons, but and ane. And you can write its structure like this. It's a bond line structure. And it goes on. Pentane, hexane, heptane, octane, nonane, decane. You should know till decane. And it's better to know for C20H42 as icosane and C30H62 as triacontane. So these are some of the alkane molecules where they have a straight chain of carbons. That means there are no branches on the straight chain. Now, what if there are some branches like methyl, ethyl, etc.? How to name these molecules? So for that, you need to follow some simple set of rules. So let's start that. I have taken 3 molecules to explain the rules of nomenclature of alkanes. For given molecule, always identify the parent chain. That is the first rule. Find the longest continuous carbon chain in the molecule and consider it as a parent chain. Here there are 3 carbons. Therefore, this will be propane because there are no branches. If there are some branches, we call them as alkyl. The alkyl could be methyl if there is 1 carbon. So remember here, if there is 1 carbon, you can call that as methyl. The meth refers to 1 carbon. If there are 2 carbons, you can call it as ethyl. If there are 3 carbons, then you can call it as propyl. And it goes on. You can see here there is only 1 carbon. So the substituent here is methyl. Once you identify the substituent, then number the chain in such a way that the substituent carbon will get the least possible number. That means what? If I number from here 1, 2, 3. If I number from here also, it's going to be 1, 2, 3. It's going to be 2. So on second position, there is a methyl. Therefore, 2. Between a number and a letter, we always use a hyphen. So 2-methyl. And in the longest chain, there are 3 carbons. Therefore, propane. Generally, there is no space between the methyl and propane. Right? So this is a complete name of the molecule. Again, choose the longest chain. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Either way, it's same. And the substituent is at the third position. And what is this substituent? Since there are 2 carbons, it's going to be ethyl. And where is it? It is on the third position. Therefore, 3-ethyl, third position, ethyl. And how many carbons are there in the longest chain? 5. Therefore, the root word is pent and then pentane. This is how you have to name the alkane molecules with the branched chain. Let's take some more examples to understand the rules. For the given examples, there are multiple substituents. That means there is more than one substituent. In that case, we use the prefixes called di, tri, tetra depending on the number of the substituents. If there are 2, we use di, 3 means tri, 4 means tetra. The rules are very simple. Choose the longest chain and make sure that the substituents will get the least possible number. If I number from left to right, right to left, anyway, the substituents are going to get 2 and 3 in this case. Therefore, we can name this molecule as 2, 3. Between 2 numbers, always there is a comma. Between a number and letter, hyphen. So 2, 3 dimethyl, because there are 2 methyl group, right? Dimethyl, and in the longest chain, in the principal chain, there are 4 carbons. So butane. And also students, make a habit of converting the content structures to the bond line structures. So for the given molecule, how can you write a bond line structure? Like this. So you can see here 2, 3 dimethyl butane. Now, for this molecule, right, if I number from here 1, 2, 3, 4, 5, 6. So both the substituents are getting 3. If I number from here, the substituents are getting number 4. And 4 is greater than 3. Then we should not use this. We should get the least possible number. So that means 3 is better than 4. So how to name this molecule now? And also you see ethyl and methyl, both are different. In that case, you can't say dimethyl or diethyl. In that case, you have to arrange them according to their alphabetical priority. So ethyl E comes before methyl M. Therefore, how we are going to name this? 3-ethyl, 3-methyl between number and letter hyphen. So 3-methyl, and in the longest chain there are 6 carbons, so hexane. Many students make a mistake by writing 3, ethyl methyl hexane. No, that is wrong. Okay, you have to write 3-ethyl 3-methyl hexane. So this is the correct way of naming this. Now let's take one more interesting molecule. Yeah, but before that, first let's convert this to a bond line structure. Always make a habit of doing it. Okay, hexane 1, 2, 3, 4, 5, 6. So you see on the third position methyl and ethyl like this. Okay, this is the correct way of writing it. Now, for the next molecule, you see if I number from here 1, 2, 3, 4, 5 and 6. If I number from here 1, 2, 3, 4, 5, 6. That means both are getting 3, 4, 3, 4. Right? In this case, what we have to do? We have to choose something related to alphabetical priority. We know that ethyl will have more priority than methyl. So it prefers to get the least possible number. So this is not correct. What is correct now? At third position, ethyl is there. That is the correct one. So that means 3-ethyl 4-methyl, because they are on different carbons, substituent carbons, right? So 3-ethyl 4-methyl. In the longest chain, how many carbons are there? 6. So hexane. And don't forget to write the bond line structures. So 1, 2, 3, 4, 5, 6. So here you see there is a methyl, and what about here? Ethyl, like this. This is how you have to name a di-substituted alkane molecules. Let's solve some more examples. Let's give the IUPAC name for the given organic molecules. What is the first rule? You have to identify the parent chain, that is the longest chain, and then you have to number it either from left to right or right to left depending on the substituents. You can see here, if I number from here, the substituents are going to get 2, 3, 4. If you start from here also, it's going to be the same. Therefore, what will be the name of this molecule? 2, 3, 4. Since there are 3 methyl, call it as trimethyl. And in the longest chain, there are 5 carbons. Therefore, it's a pentane molecule. Let's take the next example. So, how to choose the longest chain? Count the number of carbons, right? And then number it from this carbon. Why so? Because if we number from here, the substituents will get the least possible number. That way we will have the lowest sum rule, right? What exactly it means? If I start from here, the substituents will have 2, 3 and 5, right? So that would be equal to 10. But if I number from this side, right? So the substituents will have, look at this. This is the numbering, and the value will be 2 plus 4 plus 5. So that would be 11. So we should not number it from here. So this is not the correct way of numbering it, right? So now let's name this molecule. So it is 2, 3, 5. Since all of them are methyl, we are going to call this as trimethyl. There are 6 carbons in the longest chain, hexane. Now, let's take the next example. In the longest chain, you see there are 6 carbons this way, 1, 2, 3, 4, 5, 6. If we start from here, 1, 2, 3, 4, 5, 6, then which one to choose? Always choose the longest chain with more number of substituents. What exactly it means? If I choose this as the longest chain, I will be having only 2 substituents, right? So that's why if I take this as the longest chain, 1, 2, 3, more number of substituents. So this is also one of the important rules. Choose the longest chain and make sure that there are more number of substituents. Now, what are the substituents here? 2-methyl and ethyl. So alphabetical priority, and also make sure that the locants, that is nothing but the position where the substituents are present, will get the least possible number like this. Now, ethyl will come first. So 3-ethyl between a number and a letter hyphen. So 3-ethyl 2,5 dimethyl. All put together there are 6 carbons in the longest chain, hence hexane. This is the correct IUPAC name of the molecule. Now let's choose the longest chain. See, just because all the carbons are in the same line here, right, from left to right, doesn't mean that this will be the longest chain. If we take from here 1, 2, 3, 4, 5, 6, only this much. But if we take from here, this is having more number of carbons. Hence, start numbering either from here or here depending on the substituents. However, the substituents are going to get the same number, that is 3 and 6. And how many carbons are in the longest chain now? 8. Therefore, 3, 6 dimethyl octane, because there are 8 carbons. This is one of the most confusing topics among the students. So don't make the mistake of taking this as the longest chain. All right. Moving on. Same here also. You see, this should be the longest chain. And if we number here 1, 2, 3, 4, 5. So this is not the lowest sum rule. So start from here, right? So what we are going to get 1, 2, 3, 4, 5, 6 and 7. And what are the substituents we have here? All of them are methyl. Therefore, 3, 3, 5 trimethyl heptane. Heptane. Okay. Now, let's take the last molecule here. What are the substituents we have? A propyl, ethyl and ethyl. As I told earlier, choose the longest chain with the maximum number of substituents. We have 1, 2, 3 substituents. If I take like this, there will be only 2 substituents. That is the reason. Since it looks somewhat symmetrical, you can number it either from here or here. Right? Now, the propyl ethyl. So alphabetical priority. So what we have to write? 3, 5 diethyl. Students, remember one more thing. The di, tri, tetra, the first letter must not be considered in the alphabetical priority. Only you have to check for methyl, ethyl, propyl, the first letter for the alphabetical priority. Therefore, 3, 5 diethyl, 4 propyl, and 7 carbons are the heptane. This is how you have to name this molecule. Now, let's solve some more substituted alkane molecules using secondary, tertiary, and iso as prefixes. Before you start naming the complex alkane structures, it's better to learn some of the basics like what is the primary, secondary, tertiary, and quaternary carbons. When a carbon is attached to only one carbon, we call that as a primary carbon. If carbon is attached to two of them, secondary. If it is attached to three, then tertiary. If it is attached to four, then quaternary carbons. Why we need to understand this? Because these terms can be used as prefix while naming the substituents like this. Don't worry, we are not going to name this molecule right now. We are just learning how to name the substituents. So let's get started. We already know this, it's a methyl where we have only one carbon. If there are two carbons, we call this as ethyl. Now, there are 3 carbons, all of them are in the long chain. That's why we call this as propyl. Now, look at the next substrate. This is quite interesting. There are 3 carbons, but they are not in the straight chain. They are branched, right? So, in this case, right, we call this as isopropyl. Isopropyl. Okay, because a carbon is attached to 2 methyl group, then we call it as isopropyl. This is also called as methyl ethyl also, right? Now, let's see the next substrate. We have 1, 2, 3, 4, 4 carbons and 2 methyl attached to the same carbon. So that means what? This particular substrate, if I take right here, it's a secondary because it is attached to 2 methyl group. So in this case, we are going to call this as isobutyl. If there are 5 carbons, say for example like this. So 1, 2, 3, 4, 5, and then we call this as isopentyl. Okay, so basically this is a iso group. Okay, so now let's take this one. 1, 2, 3, 4. And look at this substrate. The carbon here is tertiary. Don't consider it as quaternary because it is attached to the long chain. Just we are taking as a substrate. This carbon is attached to 3 carbons. So what is it? It's a tertiary. So what do you call this now? Tertiary hyphen. You don't have to write the full name, tertiary. Just write TERT. And then since there are 4 carbons, we call it as tertiary butyl. Okay. Now let's take this 1, 2, 3, 4. But it doesn't look like tertiary group, isn't it? Because when you check for this particular substrate here, right? Only here, okay, till here, don't take this carbon. So the carbon is attached to 2 carbons. That means what? It is a secondary carbon. So because it is secondary, we call this a secondary. So SEC hyphen butyl, secondary butyl, like this. So we have N-butyl, that's a normal butyl, tertiary butyl, secondary butyl, like this. Now, let's take this one. Don't think that this is just a butyl. From the longest chain, you have to take like this from here onwards. 1, 2, 3, 4, 5. 5 of them are there. And you see there is a quaternary carbon. So why am I taking it as quaternary carbon? Because when you check till here, it is attached to 4 carbons. So in this case, since there are 5 carbons, you can call this as neopentyl. Neopentyl. Right? So these are some of the prefixes we are going to use in the common names of the alkanes as well as IUPAC names. So these are so popular, these are so common that even in UPAC nomenclature, that is IUPAC, we can use these prefixes. Now let's apply this concept on some more molecules. You can see the substrates are methyl, isopropyl, secondary butyl, etc. Whenever we have different prefix, remember the iso and neo are considered in the alphabetical priority, whereas the secondary, tertiary, and di, tri, all these must not be considered in the alphabetical priority. That means what? We should not consider the S of secondary, T of the tertiary while comparing the alphabetical priority. If it is secondary butyl, compare the B of the butyl but not the secondary. Keeping this in mind, let's name the given molecules. As usual, you have to choose the longest chain of carbons. The second step is you have to number the chain in such a way that the substrate carbons, that is nothing but the locant, should get the least possible number. If we number from this side, it's going to get the least possible number and it will obey the lowest sum rule. Now, what other substrates we have here? Since a carbon is attached to 2 carbons here, we call this as isopropyl. So isopropyl I have to compare with the methyl. So I will get more priority. Therefore, 3 isopropyl At fourth position, there is a methyl, 4-methyl. Since there are 8 carbons, octane. This is the correct IUPAC name of the given molecule. For the second molecule, this is the longest chain of carbons. Now, what are the prefixes? There is a secondary butyl and ethyl. You should not consider the S of secondary. You have to consider the B of butyl and compare it with E of ethyl. So the butyl will get the priority, alphabetical priority. So let's number from this side because both the locants are going to get the same number. If I do it from here, 1, 2, 3, 4. Here also same. That's why whenever they're on the same position, it's better to give the alphabetical priority. So we have how many carbons here? 10 carbons. So the root word and the suffix would be decane. And let's start naming from here. So it's a 4 secondary butyl, and at 7th position there is a ethyl, and all together there are 10 carbons. So decane. That is the name of the molecule. For the third molecule, let's choose the longest chain, principal chain. And now look at the substituents. This is isopropyl and this is neopentyl. So you have to consider the N, and this is ethyl. So according to alphabetical priority, E, I, N. And to number the chain, use the lowest sum rule. If we start from here, it will not obey the lowest sum rule. So we'll start from here like this. And also see how many carbons are there. There are 10 carbons. So it will be a decane molecule. Now arrange them according to the alphabetical priority. So E means what? 3 ethyl. 3 ethyl. And then what do we have? I. I means 8 isopropyl hyphen 4 neopentyl, and then there are 10 carbons there for decane. If these numbers are not in the ascending or descending order, that's okay because the priority is for the alphabets but not for the numbers. So this is the correct name of the molecule. Choose the longest chain of carbons and then number it. So I would prefer numbering from here because you see there are more substituents. Now again there are 10 carbons, so it's a decane. But what are the substituents? Methyl, and this is tertiary butyl. So the T is the one which you have to ignore and then consider only the butyl B, okay? And then ethyl. So butyl should come first, therefore 6. Tertiary butyl. You don't have to write complete tertiary. If you just write TERT, that's enough. Tertiary butyl, and then methyl or ethyl. So obviously ethyl. So 5 ethyl, and then 2 methyl, and since there are 10 carbons, decane. This is the name of the molecule. We have used the common names like isopropyl, neopentyl, secondary or tertiary butyl here. What if we use the alkyl prefixes to name the molecules? What exactly it means? Let's take some more examples and understand this. Students, there is one more way of writing the IUPAC names of the molecules without using iso, tertiary, neo, etc. So how to do that? Let's learn it here. First, we will name this molecule using isopropyl. So it is on the 4th position, right? So we can call this as 4 isopropyl heptane. What is the proper IUPAC name of this molecule? For that, what you have to do is You have to choose the longest chain from the branch. What does that mean? On the fourth carbon, there is a chain of carbons with two carbons in the longest chain. So it's a ethyl. To the ethyl, there is a methyl group. At what position? At the first position. Therefore, this group can be called as 1-methyl ethyl. So, how you can write in order to distinguish these numbers from the numbers written here, we can write them in the bracket. So, how do we write this? First, you write down heptane and then you write 4. Then you put a bracket here. The fourth is attached to ethyl, right? So, you write ethyl. But the ethyl is attached to 1-methyl. Therefore, 1-methyl. 4, 1-methyl ethyl heptane is the IUPAC name of the given molecule. Same way we can do for the second molecule. So what we can do here, number it. So 1, 2, 3, 4, 5, 6, 7, 8. So this is basically secondary butyl. So how do we usually write for secondary butyl? And there are 8 carbons, so octane. But what is the proper IUPAC name? So for that, we'll start from here, octane. You write that part. And then 4, you write that also. And then write a bracket here. Now choose the longest chain here. This is the longest chain. And what is it? Start from here, 1, 2, 3. It's propyl. So write that here, propyl. And on the first position, there is a methyl. Therefore, 1-methyl propyl. So 1-methyl propyl octane. That is the actual IUPAC name of the secondary butyl octane molecule. Let's name these two given complex alkane molecules. The substituent given here are tertiary butyl and methyl for the first molecule. And we'll choose the longest chain of carbons. So there are 8 carbons. So the name should end as octane. Now there are substituents methyl and tertiary butyl on second and fourth position. So according to alphabetical priority, the butyl should come first. Therefore, so the tertiary butyl is on the fourth position. So 4 tertiary butyl and then 2-methyl octane. We can even consider this tertiary butyl as a ethyl group with 2 methyls on it. So how to name this now? It's a 1,1 dimethyl ethyl. Whenever we have such names, say 1,1 dimethyl ethyl for the tertiary butyl group, then we consider the first letter, whether it is di, tri, etc. We need to consider that letter also for the alphabetical priority. This is very, very important here. So when you compare it with the di with the methyl M, so this will have the higher priority. Therefore, at fourth position, we have 1,1, right? Dimethyl. The longest chain is ethyl. Close the bracket, right? And then at the second position, we have methyl octane. The rest of the name is as it is. So remember, whenever we have such alkyl groups on an alkyl group, then it is always better to consider the first letter so that there won't be any ambiguity. Because when I consider methyl here and here, so there is an ambiguity. That's why we always take the first letter. Similarly, we can name the second molecule also. Choose the longest chain here like this. Now, we have ethyl and this is isopropyl. According to alphabetical priority, E comes before I. So how do you name this? 3-ethyl, 5-isopropyl. There are 8 carbons, so octane. What is the other way of naming this? So this is ethyl. What about here? It's a methyl ethyl. So as I told you earlier, the methyl ethyl will become next priority. Therefore, how do you name this? So methyl will go next. So ethyl. At what position we have it? At first position. So 1-methyl ethyl. Close the bracket. So you have named methyl and ethyl octane. So students, this is how we have to follow certain set of rules to name the simple alkanes, substituted alkanes and complex alkanes. And if you have any doubts, you can comment them in the comment section. Thank you for watching this video.